This video is going to cover the topic of tricky one-step equations. Be sure the date and topic are at the top of your page. The essential question will be, what are some strategies we can use to solve tricky one-step equations? And by now, we have worked with solving one-step equations using models and some different strategies. An example of a one-step equation we've done so far might be 3x equals 27, and we've used hangers and tape diagrams and other strategies to solve this. In the tape diagram model, you might say, I know all three of these x's equals 27, so I'm going to take my 27 and split it into 3, so I know that x must be 9. But sometimes we see what I'm going to be calling tricky problems, and it's good to have a plan or two that you can use when you see a problem that's a little bit more complicated or complex than this one. In our first type of tricky equations, I have 5 x's, but together they're a total of 1/3. They're not even a whole, and it's not necessarily as intuitive for us to figure out how much an x would be worth, because each of those x's must be really small for 5 of them to add up to 1/3. But even though it's a little tricky, this one, the tape diagram, will still really work. So I still know that there are 5 x's, and together it's a total of 1/3. So I'm going to kind of set this up as I normally do with a tape diagram. And what this is showing me is that I need to split 1/3 into 5 parts, which means I really need to do 1/3 divided by 5. But I think it's been a while since we've necessarily remembered how to divide fractions, so I'm going to do a quick review here on how to divide 1/3 by 5. So if you recall, when we are dividing fractions, we first need to make sure both numbers are fractions. So I'm going to go ahead and make sure this is a fraction by putting it over 1. So I have 1/3 divided by 5 over 1. Then I'm going to keep the first fraction as is. I'm going to change the operation to multiplication, and I'm going to use the reciprocal of the second fraction. That means I'm going to flip it upside down. Maybe I'll write flip right here. Flip it upside down, and then I'm going to multiply straight across. 1 times 1 is 1, 3 times 5 is 15. So 1/3 divided by 5 is 1/15, which means x is 1/15. And the tape diagram works really well for this one, right? It just kind of gives us a visual and then reminds us to kind of cue up our dividing fractions process. Tricky equation number 2 is a little different, right? This one still has a fraction, much like number 1, but this time I see that 1/4 of some number is 7, but I don't know what number that is. The good thing is we can still try to draw it out. So I'm still going to try to use a tape diagram, but this time we know that there is some number, and 1/4 of that is 7, but I don't know what the number is. So this is what we don't know, right? We don't know what that number is, but we know 1/4 of that is 7. So I'm going to break this into 4 parts, right? Because then this is a 4th right here, and all the other parts are 4ths as well. And 1/4 is 7, so are the other parts, right? And that means I can just then count and say, oh, 7 4 times, x is worth 28. For example number 3, we're going to do one kind of similar to that, right? But this time it says 3/8 of our number is 6. So this one's a little trickier because I'm going to have to think about how I'm going to represent this with my tape diagram a little differently. Just like the other one, I don't know what the whole number is, right? It's 3/8 of some number is 6. And since this is still talking about 8s here, I'm going to go ahead and cut this into 8 parts, which is kind of how I started example 2. But this time I know that 3 of the 8s right here are a value of 6. I'm going to mark that on my tape diagram and say that these 3/8 together are 6. Well, if these 3 together make 6, and there's 3 sections, I know that each one of these must be worth 2. So I'm going to go ahead and mark that this is worth 2, this is worth 2, and this is worth 2. But of course in our tape diagram, that means all of them are worth 2. And when I look at this and I see all these 2's, right, 2, 4, 6, 8, 10, 12, 14, 16, I know that the entire diagram must be representing 16. So my original number was 16. 3/8 of 16 is what must have gotten us 6. And in both of these cases, I think the visual really helps me to understand what I'm doing and help me figure out the value. But we could use division like we did in example number 1. I'll show you how to do that. A lot of the problems we've done so far with models, I've noticed that some of you have started to do mathematically without a visual, right? So if we go back to the first one that we did in this video, 3x equals 27, some of you intuitively decided, oh, I need to do 27 divided by 3 to get my value, right? So you're taking this total and you're dividing it by this number of x's, right? And the number of x's we have is represented by what we call the coefficient. And in fact, any problem that is set up like this can be solved by dividing the total by your coefficient. Just a moment ago, we used a visual to figure out the value of x in the equation 1/4 x equals 7. But we could do this with division as well. So we could say we know the total here is 7, and we know the coefficient is 1/4. So we could do 7 divided by 1/4 to get our answer. And we'd have to follow the same steps, right? We turn this into a fraction, keep this the same, use multiplication and use the reciprocal, and then multiply straight across, and we get an answer of 28, just like we did when we did it with the model. The second example that looked like that, we could also do the same, right? So I have my total was 6, the whole thing, or the value was 6, but we know that the coefficient here was 3/8. So I can take 6 and divide it by my coefficient. I'd make this a fraction, multiply by the reciprocal, and this time I'm going to get 48/3, but when I simplify that, that is the same as 16, which is what we got in our visual. And what's really nice about knowing that process is that we can do it on problems like this, tricky equation number 4, which I find would be a little bit challenging to model. Right? So we could use our dividing rules to help us. We're going to take what the total is, and we're going to divide it by our coefficient, just like before. These are already both in fraction form, so I'm going to keep my 2/7 as is, and I'm going to multiply by the reciprocal. And if I multiply straight across, I get 10/21. So x is equal to 10/21. And that might have been a hard question for us to figure out, but the strategy of division can really help us. For your turn, I'd like you to use one of the strategies to try to find x when we know that 2/5 of x equals 12. And I know this is a tricky equation, but hopefully we've seen some strategies we can use, which was indeed the essential question, what strategies we can use to solve some tricky one-step equations. Be sure to bring your notes, and of course we'll be practicing this more together in class.